Hello and welcome to this inaugural edition of Conversation with AI Business. And today we have Jonathan Ellis in the studio. Jonathan is co-founder and CTO of DataStax, a non-relational database company. Most of their products are, open source. And we're going to be talking about databases and machine learning. Hello, Jonathan.
Hello, Max. It's an honor to be the inaugural guest, but I'm going to have to start off by making a small correction.
Absolutely.
We're based on open source Apache Cassandra, but DataStax Enterprise is not fully open source. In fact, it's a proprietary product that's built around Cassandra.
Yes. And what is Cassandra?
Cassandra is a NoSQL database, like you said, that solves problems around scale, around performance, around availability, targeted at web and mobile applications.
Mm-hmm. And it has an interesting sort of like origin story, right? Because a lot of the open source projects, the big ones, they actually were born from, like in hyperscale data centers. So what is the origin story behind Cassandra?
Cassandra was born at Facebook. They open sourced it in the summer of 2008. And so I'm actually kind of a second generation of Cassandra developers that came to it after that initial development inside Facebook. Facebook contributed it to the Apache Foundation. And that's where I became the first committer outside of Facebook. And then I started DataStax in 2010 to commercialize Cassandra.
Okay, so when you looked at the code, what was it about it that made you think, this thing is gonna, drive applications of the future?
Yeah, I came to distributed databases actually kind of as a user because in around 2005 I was building a backup service called Mosey, and I was building the object store to hold the data that people were backing up. So it's kind of like S3, but specialized for backup use cases where you're doing a lot of writes and infrequently actually having to do restores. And the big problem that we ran into with that was managing the kind of the metadata of which users own copies of which files. And so we kind of hacked it together. The state of the art at the time was, sharded MySQL or sharded PostgreSQL, sharded Oracle if you have a lot of money to light on fire. But I recognized that as more software was going to be developed as a service, as a web application natively, as you're moving from a world where the relational databases were built to target a company's worth of users, and now you're targeting a country's worth of users at least. And this was a problem because there wasn't that kind of database technology to handle that use case. And so I wanted to help solve that problem. And Rackspace hired me to work on that for their customers. And so I got to evaluate Cassandra just after it was open sourced. MongoDB was around. HBase was around. There were a few others that you don't hear much about anymore. And Cassandra had the best kind of foundation of a powerful distributed architecture that could provide, unlike most of the others, it's not a master-slave system where, if the master goes down, then you need to have some kind of failover, maybe, run an election process to figure out who's going to be the new master. So there's downtime associated with that, with that master going down and having to bring up a new master. With Cassandra, it's a fully distributed architecture. There's no concept of a master. So any node going down, it's kind of a non-event. It's nothing has to change. Everything keeps going on, without any downtime.
Yes. And there's a couple of services that, they go down, the world cries out in anguish, and they're all using Cassandra. So I think Netflix is one, right? I think eBay is another one. Just generally, okay, so who are the largest customers for DataStax?
I'll have to get back to you on that because, we've got our largest customers and then our largest customers that I'm allowed to say their names. So I'd have to get back to you on that. But in terms of like the publicly we're speaking at conferences about how we use Cassandra, and we're not embarrassed about that. Apple runs a lot of Cassandra. You mentioned Netflix. In the streaming media space, Spotify is another one. There's a lot in gaming. Sony and Blizzard use Cassandra. So it's really a general purpose database. So we have users and customers in telecom, in finance, in media, in e-commerce, in healthcare, like just about everything you can think of.
Mm-hmm. And there's a lot of sort of like crossover between databases and machine learning projects, because obviously machine projects, learning projects need data. That data needs to be stored somewhere in some kind of format. So can you talk about how is Cassandra used for machine learning, or your DataStax product?
The most common place that Cassandra gets used in machine learning is for storing the feature vectors. So when you start dealing with data sets that are larger than will fit on a single machine, it's almost kind of, if you step back and squint a little bit, it's almost the same motivation as moving to NoSQL in web applications, where if your data set fits on a single machine, yeah, sure, use MySQL, use PostgreSQL, use Oracle, whatever. Like, it almost doesn't matter, because I don't want to say it's a toy problem, but compared to Cassandra-sized workloads, it's kind of a toy problem. And so similarly in machine learning, if you've got a data set that fits on your machine, on your desktop, there's lots of things that will work. When you start getting to really large data sets, then Cassandra is a really good solution for that. And so Uber's a good example. They built an internal machine learning pipeline called Michelangelo. They wrote a blog post about this, and it's based on Cassandra for that use case.
Okay, and another sort of like point of crossover is sort of like applying AI and automation, like things like RPA, to databases themselves. So how do you see the future of databases in this respect? Like, are they going to be self-managing?
I think we're moving in that direction for sure. And I'll drop a pitch for my friend Andy Pavlo, who's a professor at CMU, doing some really cutting edge research in this area. He's got kind of two projects in particular that are interesting here. One is called OtterTune, like the animal, OTTER. And what that does is it applies machine learning to exploring the configuration space of a database and tuning that for a specific workload. And then the other one is called Peloton, and that's a database, a research database that builds the machine learning into the database itself to tune and manage itself. So really cool stuff. At DataStax, we are we're taking smaller steps, more conservative steps, I guess I would say. So we're working on a service called Insights that will also apply AI to a given workload and make recommendations based on that workload to tune and to not just the database, but to improve your application's use of the database. So for instance, if it sees hotspots in the Cassandra partitions, then it can tell you about that and suggest ways you might want to adjust your data model to not create those hotspots. But Insights is only in the business of providing recommendations, and then it's up to a human to say, yes, this looks like a good idea. I'm going to go roll that out. So that's what I mean by it's more conservative, because it's not fully self-driving. It's making recommendations that a human can then evaluate.
Yeah, but I think database administrators would actually love that. And a lot of people are talking about augmented intelligence rather than artificial intelligence, because one is, helps you do a better job. The other is replacing you, and is a very scary idea, right?
That's true. Yeah, I hadn't thought of it that way, but yeah.
Okay, and these are like, because data scientists, they're not software developers, right? And quite often, so what you have like connecting the two parts together, like software and models as APIs, right? And you guys earlier this year have launched AppStax, which is essentially sort of like an API generation almost engine, right? So could you talk a little bit? And when you launched it, and this caught my attention, you said this could be the end of the database.
Yeah, that's a attention-grabbing quote. I would let me explain what AppStax is, and then why we would say that, and then why maybe it's a little bit hyperbolic.
Absolutely.
So AppStax is a service that helps you generate a data layer for a given service. Specifically, it's targeting microservices. And so what we do is we have you describe what your data looks like with entities and relationships. So very kind of old school in a way. That this is going to be familiar to anyone who's used entity relationship modeling on relational databases. But then what it asks you to do is tell me how you want to get data in. So for a given entity and the related entities, what do you want to insert when you're creating new records? What do you want to change when you're modifying records? And then similarly on the read requests, what data do you want to pull out together? What do you need to join together? But it's not asking you to think in terms of joins. It's asking you to think in terms of, you've defined, orders, for instance, and customers and products. So when you're requesting the order information, do you want these product detail fields with it? And how do you want those sorted and so forth? So given the the entities and relationships and the access patterns, AppStax will then compile that into a REST API or a GraphQL API that you can then just make API calls to, rather than having to operate at the SQL level or the CQL Cassandra query language level. And so the truth behind that statement of this makes databases obsolete is not so much that it makes them obsolete, but it makes them a commodity, because now you're working at a higher level, you're working at the REST API level, and the database is you're not so concerned about what configuration file for the database looks like.
Yeah. Well, I mean, because I've heard a couple of sessions on it, and it does sound like magic. And I think a lot of people who are perhaps like less proficient as like SQL are just like also big fans.
And that's exactly the idea. I was talking to, I don't remember who I was talking to yesterday, but he made I do. It was a director at Société Générale, and he said that as over the years, his impression is that the skill level of developers has gone up overall, but the skill level of developers dealing with databases has gone down, because there's so much else to worry about, and the database isn't top of mind. And so he manages an IT team that basically has to deal with those database. That inexperienced level of database developers. So his team has to kind of clean it up and make it scalable and so forth. So AppStax is really kind of going after that that skills gap and saying, hey, it's okay. You don't have to be a full stack from JavaScript all the way down to SQL. If you stick with the business logic and the user interface like that, that's where your business value is. Let us take care of kind of the plumbing and the infrastructure, and reduce that surface area that you need to worry about.
Well, it sounds great. And another question I had is you're an open source company, or partially open source. So there's also like a slightly more proprietary product. But okay, and a lot of development in machine learning is driven by open source. Like things like Spark, for example, or again the frameworks like TensorFlow, PyTorch. cafe. Why do you think, because obviously you guys like open source, it's sort of like it's the model that it sort of like keeps the company growing. Why do you think machine learning is so focused on open source? Why do you think there's so many contributors and so few kind of like large projects outside of the open source movement?
I think that's where open source thrives is where companies look at the problems they're solving with it as kind of secondary to what their business value is. So in terms of like what the problems that Google is solving, Google uses machine learning to solve problems, but like the machine learning framework itself is not, they don't see that as their competitive advantage. So they see more value in open sourcing it and getting developers familiar with their stack, and then they can hire them more easily. That's more valuable to them than keeping TensorFlow, for instance, proprietary. I think that's the dynamic that's going on there, and I think that's why.
And does that kind of also explain the Cassandra origin story? Like for Facebook, it was more valuable to get more people familiar with the technology rather than, like just keep it in-house.
Yeah, that's exactly right. Yeah.
Another question, and this is a serious question. So there are two types of database mostly, relational and non-relational. And when you talk to data scientists, they're all about structured and unstructured data. And as far as I understand, it kind of like maps onto the database landscape in terms of relational databases are great for structured data, non-relational databases, non-structured data. So yes, what is in the interplay between these two schools of, like dealing with data?
All data to be useful is structured, but sometimes the structure is less obvious than others. So Hadoop started off 10 years ago, 12 years ago, saying, hey, you don't know what data is going to be useful, so just throw it all into Hadoop and figure out the structure later. I think that was, on balance, not super successful in creating value. And for the application database space, it's very much more on the structured side of things. Of even if it's not in the relational sense of I have tables and columns, the other popular paradigm is a document database where I'm representing my objects as kind of a JSON structure. There's still going to be a structure there, a schema there. Even if it's an unstructured database, there's an implicit structure that because your application is creating it to serve a particular purpose, and so there's that structure implicit in how it's used. I actually think that that's a very bad way to build applications, because if what happens is when you create an application, if it's successful, then the data it almost takes on a life of its own, because you might have an application initially written as a Java service, but then you need to write some other team wants to write something that uses the data that it's generating, and they might write that in Python or in Ruby or in JavaScript, and so the database kind of becomes that source of truth for everyone that's consuming that data. And so if you're saying that my structure for that data doesn't actually live in the database, it's not documented, it's not enforced by the database, it's actually documented and enforced in that Java code base, that's making life harder unnecessarily for your company, for your team, for the other teams. And it's a source of errors as well. There's a paper written by some researchers at Twitter where they actually looked at using JavaScript objects in one of their services, and they actually had the example of the user ID field. Mm-hmm. And in one place, user ID was being written as an integer. In another place, it was being written as an integer but with a string data type. And in another place, it was written as user underscore ID instead of user ID without an underscore. And all of these worked fine until somebody wrote some code that wanted to look at the user IDs from all of these three pieces together. And then the problem came to light. So I would much rather define the structure up front and have that kind of documented and enforced by the database, then leave those problems latent to discover later.
Okay.
And so coming back to your original question, Cassandra is a non-relational database, but it does have a schema, and it defines that in terms of rows and columns and collections, even though it isn't relational.
Mm-hmm, mm-hmm. And I guess, yeah, and you're absolutely right. So, like, to deal with data, it needs to be sort of like in that format. So, I guess the follow-up question is: so can you, still use tools like Cassandra to basically, to flow, like there's new data sources coming in that are of great interest to sort of like data scientists. like things from like social media posts, like emails, which can be all over the place. Like video, photo. So do you see that sort of like type of content coming to live in Cassandra?
Are you getting at the question of how do I deal with data where the data source may be adding additional fields that I wasn't aware of initially?
Well, stuff like that.
Yeah. You can deal with that in Cassandra by often I mentioned collections as a data type. So you can say that I have a map of data. That's my column type is a map, and if I could say it could be a map of string keys to string text, and that'll allow me to accommodate fields that I didn't necessarily know about ahead of time without going full on. Hey, I have absolutely no idea what's in this data.
Okay. Thank you. I think that's everything we have time for today, but thanks for watching, and thank you, Jonathan.
Thanks for having me, Max.